Hello friends, welcome to our channel Physics for You. And as you can see on the screen, in this video we are going to learn about applications of ultrasonic waves. Not only application but applications, different applications of ultrasonic waves. Okay, so already we have seen 4 or 5 videos regarding these ultrasonic or ultrasonics. So in these ultrasonic waves or ultrasonics, we have seen basically what is ultrasonic means, or what is ultrasonic wave means, and how to produce ultrasonic wave. And in the last video we have seen how to detect ultrasonic waves and how to calculate its velocity. Okay, so this is all what we have done, and now finally we are going to learn, or we are going to see about the applications of ultrasonic waves. And yes, maybe or not, I'm sure this is the end, or this is the last video in regards of ultrasonic waves. Okay, and moreover in regards of the acoustic and ultrasonic, this unit we have seen two different parts. Initially we have seen about the acoustic, and the second part is what about ultrasonic. So again, this is also the last video regarding this unit. Okay, right, so let's begin. Let's see what are the different applications of ultrasonic waves. Now we are very well aware about the production and the detection of ultrasonic waves. So let's move towards the application. So the first basic application is to find the depth of sea. Everybody have seen or everybody have, I think, already known that the depth of sea is calculated, or depth of sea is found by using ultrasonic waves. That is what we know, the sonar system. Yes, might you have already, maybe you have seen this type of diagram in your school level. Yes, this is what a ship, and in this ship we have what this is, and we have one sender here, or the ultrasonic wave, we can say producer or oscillator, which produce the ultrasonic waves, and we have one more here is the receiver. Yes, and these ultrasonic waves will pass through the ocean, or will pass through the water. And if let us consider this is the depth, so from depth it will reflect, right, and the receiver, after reflection, receiver will receive the ultrasonic waves. And yes, by this we can find the time required for these ultrasonic waves to reach up to the depth or end of this sea or ocean, and again to reach up to the receiver. Once you know this time difference, then we should divide it by 2, because we just want to find this difference or this distance, right? So actually here actual time to reach up to the depth is delta t by 2, because delta t is what the total time required as soon as it leaves the oscillator and comes toward the receiver. Once you know this time, right, and we if we are having time, then that we can find the frequency. Frequency is equal to 1 by time. From that we can find the time period. Basically from this we will find base time period. This is time required for one particular cycle, so that is time period, and 1 by time period will give you the frequency. Once you know the frequency, and velocity of ultrasonic wave is known to us, or we can find by using acoustic grating method. If you haven't seen that video, I will post the link of this video, that video, in the description box of this video. That is how to detect the ultrasonic wave and how to get the velocity of ultrasonic wave. Now the frequency and velocity is known to you, then yes, simply we know that frequency, or we can find the distance, or by using the velocity we can find it is nothing but, velocity is nothing but distance upon time. Okay, so time is known to us and velocity is known to us, and by which we can find distance is equal to velocity into time. So this is how we can find the depth of sea by using the ultrasonic waves. Okay, this system is called as sonar system, right? Sound navigation, and we can say the reflection method, right? Okay, the second one is what, for directional signaling. Again, in different regions, or in different we can say the areas of our country, or in overall world, some cable networks or some towers are not possible to launch, and in that case the ultrasonic waves help us for the signaling purpose, directional signaling in a perfect direction or in a specific direction. Again, to heat the given substance, right, you can imagine how we can use these ultrasonic waves to the heating purpose, because we know that whenever the ultrasonic waves are passing through a medium, the density of the medium changes, the refractive index changes. Similarly, these ultrasonic waves gives energy to the atoms in the substance, whether it is solid or liquid, or it is possible in case of gas also. The ultrasonic waves can heat the gas, that means gas can goes to, or the gas molecules or atoms can goes to the higher excited state, and once they are in a higher excited state, right, and if they are coming back to the lower state or ground state, they will release the energy, or they will release in the form of heat. So this is how we can use ultrasonic waves to heat the substances. Next one, ultrasonic waves are used to drill, or ultrasonic drills, those are known as drills, ultrasonic drills, to bore the holes in even steel and other metals, right. So in metals it is very hard to having the bore, or metals are hard enough to drill from themselves. So there, without having any mechanical drilling machine, we can use the ultrasonic drills. So ultrasonic drills easily will help you to bore the metals or steels or some other substances or hard materials, we can say. Again, the next one, to detect the cracks or the discontinuities in the metal surfaces. Yes, because when you are working in a metal industry or steel industry, so long or heavy rods of the metals are produces, or general production is going on. And if I am producing a rod like this, let us consider, I will draw a little bit zoom rod, and in this I have we will have one particular vacancy or a air bubble, because we know that initially this rod, before making, if we are talking about the steel rod, then we are having steel in a molten form, and then the industrial people or the workers who are working there, they will pour that into a shape in which you want the rod, whether it is cylindrical, or sometimes we are having the rectangle rods also. So if let us consider, by in pouring process, we are having some dust particle or a air bubble is there, and that can cause the crack in the metal, or that can cause some discontinuity. So the by passing the ultrasonic waves through that, we can having the velocity difference, and we will just have one detector here, and by using, we can check whether the ultrasonic waves are coming through the same medium, or there is some difference between the refractive index. And if there is difference between refractive index, then we can see, yes, this is a metal region, and here somewhere is we are having some air bubble. So this is how we can detect the cracks and the discontinuities in the metal by using our ultrasonic waves. Next one, to form the alloys by using the ultrasonic mixer. That means ultrasonic waves, if we are talking about the alloy materials, so I want to just first of all heat those materials. We have to mix, we can call it as stirring purpose also. So two different materials I have kept in a particular boiler, and so it is not easy to mix them together with some mechanical process, because they are melting at a very high temperature. So simply by passing the ultrasonic waves, we can mix them together very well, we can stir them together very well. So in short, we can say, instead of saying the ultrasonic mixers, we can say ultrasonic stirring machines, right. Stirring can be possible using ultrasonic waves. Next one, ultrasonic waves can be act as a catalyst. This is again an important application in case of chemistry also, or in some chemical industries also, where they want to increase the rate of reaction. What is the role of the catalyst? We know that catalyst is a, chemistry people might know in better way. Catalyst, whatever I know, I will tell you what is catalyst. Catalyst is that particular thing or that particular agent which is not taking part into the reaction, it does not take the part into the reaction, chemical reaction, but it can increase the rate of reaction. Yes or no? Increase the rate of reaction. So for such a purpose also, our ultrasonic waves can work very efficiently. So they can work as a catalyst. Okay, next one, for soldering purpose. Ultrasonic valves means some metals or some materials or substances like aluminium cannot solder together with some our what we can say the normal soldering purpose or by some normal soldering method. So for aluminium we need some another soldering technique, and therefore generally we are using ultrasonic soldering only. So soldering is also one of the application of ultrasonic valves. Yes, this is one of the important fact or important application. All are important, but this is more common to us. We can say medical applications. So medically, ultrasonic valves are used in several. We can say the medical purposes or several medical purposes. First one is for relieving the neurologic and the rheumatic pains. So neurologic, which is related to the brain, and this rheumatic means we called in Marathi as a Sandivat, right? So it is what related to we can say bone pain like, right? So these ultrasonic waves can help to relieve these pains or to what we can say make the low intensity or to decrease the intensity of these pains. The ultrasonic waves can be can be useful. That means ultrasonic waves will pass through that particular organ, and if some tissues and some bones are having some little bit issue of we can say we can have this rheumatic problem, then they can act as a massage, or the ultrasonic wave can give a little bit massage to that particular organ, and the patient will have little bit relief from the pains. This is what one of the example or one of the application. Next, for relieving pain due to the arthritis, so arthritis, yes, obviously these are the two different things, same things we can say rheumatic and arthritis is also the it is related to bone only. So those pains also can be relieved from ultrasonic wave massage. Same technique will be here. Then these waves or ultrasonic waves used by dentist for proper extraction of the broken tooth. Again, as I told in case of our metal detection of cracks and the discontinuities, same is applicable here also, because the dentist want to know exactly where is the break or the crack or some defective tooth present, and for that they are also using the ultrasonic detectors so that they can exactly go to that tooth and they can cure, right? And again ultrasonography, it is known to everyone for stomach problem and all. Whenever you are having some problem with your stomach, so generally we are going we go to the lab, and or whenever you go to the doctor, they will always suggest you to take the sonography so that we can detect something is there or not. Or whenever you are having the kidney problem, yes, kidney stone and something like that, then also you have to take the ultrasonography, and in which we can detect, or that doctor can detect how much is bigger stone is and how to cure it and all this, right? And some bloodless surgeries also done by the ultrasonic waves also. So just I told about this kidney. Now in previous days, these kidney stone operation was very much complicated, and people are little bit scared about this, because I think some stitches have to be done. But nowadays this kidney stone operation is also stitchless operation, we call this as stitchless. So that is possible with the help of ultrasonic waves or bloodless surgery, right? So these are what number of medical applications. And one more is that for sterilization purpose of water and milk. So the sterilization or the ultrasonic mixtures already we have seen, but in this food industry also, water and milk means we generally see the milk, right? Milk, Amul butter and all these things. So in those industries, from what we know, buttermilk, we have to shake very well, we have to stir very well, so that from that we can take out the butter and all. So for those purposes, because the amount is very large or the volume is very large, right? 1000 liter buttermilk you have to shake, so it is not possible by manual or not other some mechanical process also. So there simply they will pass the ultrasonic waves through that buttermilk, and that buttermilk can stir and the butter can take out by some other processes. So this is how In food industry also, we have several applications, or majorly these applications as a sterilization of ultrasonic valves. Yes guys, if you know other applications than this, you please post in the comment box. I just want to know, or I just want to convey with you that there are several applications of ultrasonic waves, because I think whatever you are learning, you should know the applications of those things. So ultrasonic waves we have learned only, not only the ultrasonic waves, we have learned ultrasonic waves very in a very clear manner. We just have seen first of all the definition or the basic thing, what is ultrasonic wave, then we have seen the production, then we have seen the detection, how to detect, and then we have seen the applications. So this is what the basic thing. If you are looking forward for learning anything, or to learning new thing, we should take in this manner only, how to define that, or how what is that concept, then how to produce that particular thing, then how to detect, and is there or are there some applications of that thing. And yes, there are several applications of our ultrasonic waves that we have seen in this video. So guys, this is all about ultrasonic waves. If you have any doubt, you please post in the comment box. Otherwise, if you feel this is value addition to your knowledge, then yes, like this video, subscribe to our channel, share with your friends, and press the bell icon so that you will get the notifications of our next video. Right? So you'll meet in the next video with new concept. Till then, please take care and keep learning. Thank you so much.